Have you ever looked up at the night sky and wondered just how big it all is? The universe is so vast that it's hard for our brains to even begin to understand its size. But today, we're going to try. We'll take you on a wild ride from the tiniest particles to the largest structures we know of. By the end of this video, your mind will be spinning with the sheer scale of everything around us. Get ready to feel very, very small, but also amazed at the incredible cosmos we're part of. We'll explore mind-bending distances, gigantic celestial objects, and the tiniest building blocks of matter. We'll meet scientists who study the universe and learn about the tools they use. So, grab a snack, get comfortable, and prepare to have your mind blown as we uncover just how enormous our universe really is. Let's begin our cosmic journey with something familiar, our home planet, Earth. At about 12,742 kilometers in diameter, it might seem pretty big when you're standing on it. But in the grand scheme of things, Earth is just a tiny speck. To help us understand this, let's do a fun experiment. Go grab a grain of salt from your kitchen. Got it? Good. Now, imagine that grain of salt is Earth. On this scale, the moon would be about the size of a tiny speck of dust, and it would be about 30 centimeters away from your salt grain Earth. To put things in perspective, let's imagine Earth as a grain of sand. If Earth were this small, the Sun would be about the size of a baseball, and it would be nearly 15 meters away from our sand grain Earth. That's already a pretty big distance, right? But we're just getting started. At this scale, Jupiter, the largest planet in our solar system, would be about the size of a marble and would be about 80 meters away from our sand grain Earth. Now, let's zoom out to our solar system. If Earth is a grain of sand, and the Sun is a baseball 15 meters away, how far do you think the next nearest star, Proxima Centauri, would be? Hold on to your hats, it would be about 4,700 kilometers away. That's like going from New York to Los Angeles and back again. Can you imagine the vastness of space between stars? It's mostly empty, with just a few particles of dust and gas floating around. But our solar system is just a tiny part of the Milky Way galaxy. Our galaxy contains an estimated 100 to 400 billion stars, each potentially with its own planets. If we stuck with our sand grain Earth, the Milky Way would be about the size of North America. That's a lot of space. Let's take a moment to consider the different types of stars in our galaxy. Some are tiny red dwarfs, barely larger than Jupiter. Others are massive blue giants, hundreds of times bigger than our Sun. And scattered throughout are the remnants of dead stars, white dwarfs, neutron stars, and even black holes. Each of these objects tells a story about the life cycle of stars and the evolution of our galaxy. Now, here's where things start to get really mind-bending. Our Milky Way is just one of billions of galaxies in the observable universe. The Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light-years away. A light-year is the distance light travels in 1 year, about 9.5 trillion kilometers. So, Andromeda is about 23.7 quintillion kilometers away. That's a 23 followed by 18 zeros. To help visualize this enormous distance, let's try another thought experiment. Imagine you could travel at the speed of light. At this incredible speed, you could circle the Earth 7.5 times in just 1 second. But even at this unimaginable speed, it would take you 2.5 million years to reach Andromeda. That's longer than the entire history of human civilization. But even Andromeda is close compared to the size of the observable universe. The observable universe is everything we can see from Earth, limited by how far light has had time to travel since the Big Bang, about 13.8 billion years ago. This means the observable universe is about 93 billion light-years across. If you're having trouble imagining that, you're not alone. It's almost impossible for our brains to truly comprehend such vast distances. To help visualize this, let's use a different scale. Imagine the entire observable universe was the size of Earth. On this scale, our Milky Way galaxy would be about the size of a bacterium, and our solar system would be smaller than an atom. That's how incredibly tiny we are in comparison to the whole universe. But here's something even more mind-blowing. The observable universe might not be all there is. Many scientists believe the universe could be much, much larger than what we can see, possibly even infinite. We just can't observe beyond a certain point because light from those distant regions hasn't had time to reach us yet. Now, let's take a moment to consider the challenges of studying something so vast. One of the biggest hurdles astronomers face is the sheer distance involved. Even with our most powerful telescopes, we can only see so far. And because light takes time to travel, when we look at distant objects, we're actually seeing them as they were in the past. When we observe a galaxy 10 billion light-years away, we're seeing it as it was 10 billion years ago. This leads to an interesting question. What does the universe look like right now? The truth is, we can never know. We can only see the past, never the present, when we look into space. It's like having a time machine that only goes backward. Dr. Neil deGrasse Tyson, a famous astrophysicist, once said, "The universe is under no obligation to make sense to you." This quote reminds us that the cosmos operates on scales and principles that often defy our everyday understanding. To give you an idea of what it's like to study the universe, let's imagine a day in the life of an astronomer. Dr. Sarah Chen wakes up at 2 a.m., ready for a night of observation at a large telescope. She's studying distant galaxies, trying to understand how they formed and evolved over billions of years. As she peers through the telescope, she's essentially looking back in time, observing light that has traveled for millions or even billions of years to reach Earth. Each image she captures is like a tiny piece of a vast cosmic puzzle. As the night progresses, Dr. Chen collects data on hundreds of galaxies. Some are spiral, like our Milky Way, while others are elliptical or irregular. She notices patterns in the distribution, clumping together in great cosmic webs with vast voids between them. These structures, formed over billions of years by the gravitational dance of dark matter and normal matter, are some of the largest known in the universe. Dr. Chen faces many challenges in her work. The faint light from distant galaxies is hard to detect, and Earth's atmosphere can distort the images. She uses advanced computer algorithms to clean up the data and reveal the true shapes of the galaxies. Sometimes, she collaborates with space telescopes like Hubble or James Webb, which can see even farther into space without atmospheric interference. By dawn, Dr. Chen has collected a wealth of data. But this is just the beginning. She'll spend months analyzing this information, comparing it with theoretical models, and collaborating with colleagues around the world. It's painstaking work, but every discovery brings us one step closer to understanding our vast cosmic home. The study of the universe's size and structure has profound implications for our understanding of physics and the nature of reality itself. For example, the discovery of the universe's accelerating expansion led to the concept of dark energy, a mysterious force that seems to permeate all of space. This discovery fundamentally changed our understanding of the cosmos and earned its discoverers the Nobel Prize in Physics in 2011. Let's talk a bit about the history of our understanding of the universe's size. For most of human history, people believed the Earth was the center of everything, with the sun, moon, and stars revolving around us. It wasn't until the 16th century that Nicolaus Copernicus proposed that the sun was at the center of our solar system. This idea was revolutionary and took many years to be accepted. In the early 20th century, astronomer Edwin Hubble made another groundbreaking discovery. He proved that the fuzzy patches of light astronomers had been observing were actually entire galaxies outside our own Milky Way. This dramatically expanded our understanding of the universe's size. Hubble also discovered that these galaxies were moving away from us, leading to the idea of an expanding universe. Looking to the future, new technologies promise to expand our view of the universe even further. The James Webb Space Telescope, launched in 2021, is peering farther into space and time than ever before, potentially revealing galaxies formed just after the Big Bang. Future gravitational wave observatories may allow us to hear the echoes of the Big Bang itself, giving us a new way to study the early universe. These advancements could help us answer some big questions. Are we alone in the universe? What is dark matter and dark energy? Is there a multiverse? The answers to these questions could revolutionize our understanding of reality itself. But the study of the universe isn't just about science, it also impacts our culture and philosophy. The famous pale blue dot photo, taken by the Voyager 1 spacecraft as it left our solar system, shows Earth as a tiny speck in a vast cosmos. This image has inspired many to reflect on our place in the universe and the importance of taking care of our small, fragile planet. As we wrap up our cosmic journey, take a moment to reflect on your place in this vast universe. We are incredibly small on the cosmic scale, yet we're made of the same stuff as the stars. The atoms in your body were forged in the hearts of ancient stars that exploded billions of years ago. In a very real sense, we are the universe becoming aware of itself. The next time you look up at the night sky, remember the incredible scales we've discussed. Each point of light you see is a sun, potentially with its own planets, and beyond that are billions of galaxies, each with billions of stars. The universe is more vast and more amazing than we can fully comprehend, and that's what makes it so fascinating to study. Now, let's do one final thought experiment. Imagine you could shrink the entire universe down to the size of your school. On this scale, our entire Milky Way galaxy would be smaller than a single atom. You wouldn't be able to see it even with the most powerful microscope. And yet, within that invisible speck would be hundreds of billions of stars, including our Sun, and billions of planets, including Earth. It's mind-boggling to think about, isn't it? So, what does all this mean for us? Does our tiny size in the vast universe make us insignificant? Or does our ability to understand and appreciate the cosmos make us special? These are big questions without easy answers, but they're the kind of questions that studying the universe encourages us to ask. As we continue to explore and understand our universe, who knows what amazing discoveries await us? Maybe we'll find life on other planets, or uncover the secrets of dark matter and dark energy. Perhaps we'll even discover new dimensions or parallel universes. The possibilities are as vast as the cosmos itself. What do you think about the size of the universe? How does it make you feel? Share your thoughts in the comments below, and if this video blew your mind, don't forget to like and subscribe for more cosmic content. And here's a question for you to ponder. If you could travel anywhere in the universe, where would you go and why? Until next time, keep looking up and wondering about the incredible universe we call home.